So what would happen is a new vendor that's coming into the space would build a new router and will have a module which can understand all these OpenFlow APIs. So once they understand it, they'll be able to program their hardware. So now vendors can come and say, I'm OpenFlow compliant. So anybody can come and work on it, and any controller will be able to talk to any device. That's the good part. So you would ask, then what would vendors like Cisco and Juniper do, right? If everybody is just making their own devices, then there's no play for us. But the deal is that they have their own APIs, and what we have to remember is the thing that these companies bring in is the extremely good hardware forwarding engines that we have, right? So if we can expose APIs that will allow the controller to exploit those the hardware functionalities, then we are good. So it's not like anybody is getting killed in this space. Everybody wins. It's just a new shift. So this OpenFlow, like I said, so it's a protocol between the controller and your OpenFlow switch. And every switch needs to have this a module which will understand these OpenFlow APIs. And everything is flow-based, if that makes sense to you, because the reason it's called OpenFlow is because the way it's done is whenever you want a packet which comes in to go to a particular destination, then you would classify that packet as a flow. A flow could be just made up of a destination address, a source address, or a combination, or with a protocol. So you would just say that if a packet comes in with this source, this destination, this port number, do this to the packet. That is the information the controller will give to your hardware, and the hardware programs it. So next time packet comes in, it hits this flow, and then does whatever it wants. I mean, whatever it has to do with that packet. That's why it's called the open flow in some sense. So the open flow brings in some advantages like programmability. Now anybody can, who wants to change the network, will just call one of these OpenFlow APIs to change what they want in the device. The other thing is it's very granular, right? So with the API, you can control one particular ACL applied on one interface and one switch. So you can go as granular as that. And again, I have to talk about apps, because today apps is the king, right? Everywhere, from mobiles to the networks now. So with these apps are the ones that are going to use these OpenFlow APIs or talk to the controllers who use the OpenFlow APIs to dictate how the network is going to be. So let's hear a little more about how this happens. Tulika.
Hey, thanks, Lakshmi. So yeah, as Lakshmi started by talking about the change or paradigm shift. So the shift is actually brought a lot by apps. So today we have a lot of these new apps which use which are very networks intensive, like there is videos, photos, maps, or even social networking or doing hangouts or like live video streaming. And with the applications becoming so WAN intensive or network intensive, we need to make sure that the costs of network is actually coming down, because it's kind of like the way we see with computers and storage. As computers become more and more powerful, they also start becoming cheaper. So it's getting even more easier for you to buy a very, very powerful computer. But unfortunately, this wasn't happening so much with the networks. So the cost per bits was not going down. A lot of it was because there's a lot of manual management required, which means that you have to always add this cost of manual interventions. So now what's the solution? So for apps, the best thing is that if we can treat this WAN as a fabric. Now what this means is that basically we treat routers as fungible resources, meaning it doesn't matter whether a router is up or down. What matters to the app is that the data or the bits flow from one point to the another. Doesn't matter how they get there, but they should get there, and they should get there in time. So that's how at least the apps want to see the network. Now current equipments don't allow that, because as Lakshmi mentioned is that a lot of things have to be configured on the boxes. It has a very, very box-centric view. And also the whole network is designed for eventual consistency, or eventually everything, if something fails, then eventually everything will become all right. But that's not what apps want. So to give an example of what I'm talking about, let's say it's a very, very simple network of like 6 routers. And the edges here represent the capacity, and we want to send some traffic from R1 to R6, R2 to R6, and R4 to R6. Now this is what the system looks like in its stable state. No problem. Now let's say that a link between R5 and R6 breaks. So today what happens is that when this link breaks, then all of these routers are going to independently try to figure out how do I transfer my traffic to R6 now. Now let's say in the first round, all of them try to go through the link at the bottom. So now only one of them is going to win because the network doesn't have enough capacity. So in the first round, let's say R1 wins. Now R2 and R4 have to try again. And again, it's possible that they will try to go through the same channel, and now one of them will again win, another one loses. So we're kind of doing this very iterative trial and error process, which takes a long time, and now the traffic from R4 is actually almost dropped. So here the central controllers actually come in like a really obvious solution. So when you have centralized traffic management, what is going to happen is that all the routers will tell the central system about what are they seeing, what is the picture of network they have. And if anything goes down, the central network can in one single flow, single go, say to each of the R1, R2, R4 how they should send their traffic. There's no trial and error required, there's no iterations required, everything flows smooth and fast. Now what are the advantages of this central controller? So first of all, it gives us a much better network utilization because the central controller has a global picture. So it knows how the whole network looks like. It knows that if something is failing, then how it can send traffic, read out the other traffic. So which means that it can converge faster on failure because there is no more trial and error required. It can also increase utilization. Now how? Because since we have the central controller, we make the network a lot more deterministic. We know that the central controller is going to figure out how it's going to send the traffic, and which means that we don't have to build too much redundancy in the network. Like we saw in the previous example that where routers were trying and they were kind of overstepping each other's traffic, which means that you kind of want to build more redundancy in the network so that they don't really overstep onto each other's toes. So now with central controller, we bring in more deterministic behavior, and we say that, yeah, we can live with a little bit of less redundancy, which means that we obviously increase our utilization, we make everything more efficient, fault tolerant, and which obviously drives the cost down because now we don't have to build so much extra redundancy here. More advantages. So as we were talking about applications, now there are applications have priorities, right? For example, you can say that something like search would be very high latency sensitive because there's a user actually waiting to receive results. But something like email, maybe it's not that latency sensitive because it's kind of an offline thing. So now when you talk about a central software which is controlling how traffic flows, you can build this kind of logic into the software. You can say, hey, if you see an email traffic, you can give it a little bit lower priority. If you see a search traffic, make sure it goes through as fast as possible. And this is really, really handy when it comes to failures, because now you have a failure, and now you have this whole module which can decide how to send the traffic in the best way. So that's one big advantage. But then another advantage is testability. So like Lakshmi talked about how people are very afraid that you touch their network and something will go down. And this fear comes from the fact that it's not, you don't exactly know how to test your network, right? And so you're worried that if you make a change, you don't know how to test it and things can go down. Now when we make everything in the software, now it's very easy to test because you can easily simulate you can create virtual environments, simulate your network, and you can also, each software module can be individually tested and to make sure that it works the way it's supposed to work. And also now that we are making them separate software modules, we can attach monitoring to each of them. We can say that is this part of the network working fine, or is this part of the network working fine? So it makes testing very, very easy, and with the more testing, it makes people a lot more confident that yes, their system is going to work. So just to like sum it up, why software-defined networks are really, really important for applications. First of all, we saw that it improves the utilization. So we don't have to build too much redundancy. We can make really highly efficient networks. It gives us more deterministic and fault-tolerant behavior. And then we separate hardware from software. So Lakshmi Gayatri is going to talk later about how the separation happens. But you separate them, and then you can improve testing. You can update them independently. You can use the best technology with the software and with the hardware when it catches up. And also monitoring is very, very important. That's kind of one of the really critical things for us is you can monitor every part of the system individually, and you can find and fix problems on individual part of the system very efficiently. So as a result, you end up with a WAN which is much higher performance, which is very fault tolerant and much cheaper. So now you can scale it up and you can send as much traffic through it as you want, and things work. So now I'll hand it over to Lakshmi Gayatri to complete the full story.
Thanks, Tulika. So you already heard from Lakshmi Mukund and Tulika. They have spoken about the networking and the applications part. Yeah, applications is the king. It's all about applications. They are one of the driving forces of the new architectures which we are seeing now. I'm going to talk about the other parts of the building block which constitute a software-defined data center, the compute, storage, automation and management, and I'm going to consolidate what it takes to SDDC. So these three are the forces at work which we all agree to. The first thing is about the hardware costs. The hardware costs are coming down day by day with the innovation which is happening in CPU and memory. We are packing more and more memory. The machines are becoming highly density. The density is very high. Ravi had spoken about like supercomputers and all. We have like very high RAMs, we have very good CPU capacities on the servers. So because of this, I mean, you're packing more and more on one server, and your server becomes like super server. So, and then the second factor is about the virtualization of all hardware. At one point of time in the past, there was a question like, will the data centers be at least 50% virtualized? Now the question which is being asked, why are they not at 100%? When are we going towards the 100% of virtualization? So the graph is actually going up, very steep up. And the third thing, applications, as I previously said, it's the most important thing. The breadth is actually increasing. The east-west traffic is increasing. Your videos, your data, the data is becoming huge. So it becomes a challenge on the cloud part wherein he has to store the data in a very cheap manner because we cannot have any high-end of FC storage and all to have this kind of data which is actually written just once and then read multiple times. And this forms the new architecture model for the data center. Let's try to define what an SDDC is. As Lakshmi and Tulika had hinted in their previous presentations, we are trying to use software as much as possible. So the specialized software which we have is going to replace the specialized hardware. So how we are going to define SDDC? It's made of building blocks, essential building blocks, which are virtualized hardware, that's your compute layer, which was at the back of the elephant, which Lakshmi had unraveled. And we have software-defined storage, software-defined networking and security, and last, we have to manage and automate all these things. It's not just that everything is software and then individual APIs, you have like 50, 100 APIs or something. Every software comes with its own APIs. You'll have to automate all these things. It's not easy. So now let's talk about the compute layer, the first layer what we have at the bottom, which is the most essential thing. And there have been innovations happening in this field for over like 5, 6 years or even more than that. Here is what we see. It's actually a little lighter. Okay. So we have 3 ESX machines here. We have got ESX machine 1, 2, and 3. And then this is a resource pool. We have a resource pool. So what is the advantage of resource pooling? So I have 10, you have 10. Together it is 20. So we can together buy a commodity which is like 15 rupees or something. So when there are machines coming up with RAM, which is like 4 gig, 8 gig, and 32 gigs, right? So when they form a pool, it all becomes like a togetherness. I mean, we are pooling resources. The pooling is possible only with virtualization. We are abstracting the hardware with software. So here you are seeing 2 virtual machines which I have highlighted in the blue boxes. So these are the applications at this point of time which are requiring high memory. So when these applications are falling short, there is an I/O control which happens. It detects that these virtual machines need more memory. So in the 3 machines, whatever you see at the bottom, the third one has 32 GB RAM. So the application, what automatically it does is the policies, because of the policies which are coming, it migrates the virtual machine from a ESX which was running on 8 GB RAM onto a 32 GB RAM. The end of the story, what we are going to say, the applications will be happy throughout. So in order to make them happy, and the end user would not even know that something of this migration has happened at the back end. So it's all automated. And next comes the storage resource pooling, the second level. So in storage, what we have, it's like we have 3 levels of storage, right? We have your local disk, which comes with all the hardware which you are buying, and the second is a scale-out storage, which can be your IP storage or anything, and then the third is the cloud storage. So blob is the binary large object. So this is where the data is like very huge. You write once and read multiple kind of data. So the local storage, now with the newer technologies, we are using local disk more and more. Earlier it was like every machine, whatever we had, we used to put it in a SAN, and then all the data used to go up into some storage arrays, and we used to back up to that magnetic tape. But now local disk is gaining more and more importance because of the newer technologies which are coming in. We have flash and SSD. So because of that, many even applications also, right, like Gemfire and Cassandra, they support distributed systems, and they're using more and more of local disk. Next, we'll talk about the storage I/O control. So on the left is what you do not want to see, wherein you have your online store and Microsoft Exchange. You have 2 of these applications which are running on a data store. So on your data store also, we'll have to put a policy in such a way that whenever the virtual machines or the applications which are running are not happy, they are like cranking or they're complaining that they are not getting enough I/O, they will have to be made happy. We will have to place them in such a way that the critical applications which are important for your business continuity are always given the higher importance. The priority has to be more. So that's when you give higher priority to these particular virtual machines which are running your business critical applications. So what you see here is when, if you do not have a storage I/O control, this is where you end up with, which you do not want to. So if you have a I/O control which is incorporated in, it actually comes with the data stores and how you manage it. So you will make your online store and the Microsoft Exchange depending upon your business criticality. These are just an example which I have put. These will be happy. I mean, because they are getting whatever I/O they wanted on that particular data store. And the data mining application, which is not a P0 for your business continuity, but still it is important, it will be satisfied with whatever resources it needs. So next we are talking about the initial placement. Now we are talking about a data center, right? Now we are at a very higher level. So when you have some virtual machines coming in, here again we are talking about pooling. So here you see a 500 GB data stores. There are like 4 of them. Together they form 2 terabyte. The advantage of pooling, again, you can accommodate and make use of the free space. When there is a 500 GB, you have the available space which is mentioned at the bottom. So together they will be able to accommodate the VM which is coming with a higher space. Here what we are doing is, we are trying to see how the initial placement happens. So again, storage I/O control comes into play, identifies which of the data store has got the maximum space or whatever it suits its SLA. Wherever it wants to go, it will just check according to its requirements. And then here we are looking at the size part, wherein it has chosen the 300 GB is the size which it has to go to here. And then the virtual machine which is coming into the data center automatically places itself into the data store which it thinks is the winner. And this is about the initial placement.